or DAX to solve a number of basic calculation and data analysis problems. We'll go over some conceptual information and a series of tasks to knowledge check what you have learned. After completing this session, you should have a pretty good understanding of most of the fundamental concepts in DAX and be able to use them with a little bit more practice. But before we begin, let's look at our agenda for today. So first of all, I'm going to talk a little bit about DAX. What is DAX? Why is it so important? Certain prerequisites which will help if you are familiar with, and if not, don't you worry, it's a from scratch tutorial anyway. Then we are going to frame our understanding around the fundamental concepts of DAX. Then we are going to discuss the different kinds of functions available to you. So first we are going to look at some count functions, followed by which we are going to see some logical functions. Apart from that, we're going to look at some information functions and text functions, and finally conclude with some datetime and time intelligence functions. I'm going to be picking up a few of the most popular or most used functions and then run them by you on the Power BI desktop so you have a better understanding of how these work. With that, we come to the end of our agenda. Also, kindly take up this time to subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. So without much ado, let's get started. So what is DAX? Now DAX is a collection of functions, operators, and constants that you can use in a formula or an expression to calculate and return one or more values. It is the native formula and query language for all of the data analytics tools in Microsoft, and it is also a very highly versatile and functional language designed to work with relational data and perform dynamic aggressions. Simply put, DAX helps you create new information from the data already present in your model. But why is it so important? Now, it's easy to create a new Power BI desktop file and then just bring some data into it. You can even create reports that show some valuable insights without using any formula at all. But what if you need to analyze growth percentage across different categories for different dates? Or you need to calculate year-over-year growth compared to market trends? Data Analytics Expressions, or DAX, will provide you with this capability and many other important capabilities as well. Learning how to create effective DAX formulas will help you get the most out of your data. When you get the information you need, you can begin to solve real business problems that affect your bottom line. This is the power of Power BI DAX, and this is the part of the technology that will help you get there. Now, you might already be familiar with creating formulas in Microsoft Excel. I am hoping most of you have actually migrated from Excel to Power BI. That knowledge will be very helpful to you in understanding DAX. But even if you have no experience with these Excel formulas, the concepts that are described throughout the session here will help you get started with these formulas and solving real-world BI problems right away. We'll focus on understanding DAX formulas used in calculations, more specifically in measures and calculated columns. You should already be familiar with using the Power BI desktop at this point so that you can import data and add fields to the report. And you should also be familiar with the fundamental concepts of measures and calculated columns. If you haven't, I will also link a basic tutorial for you guys in the description box below. Now we'll frame our understanding of DAX around three fundamental concepts. You have syntax, functions, and context. These are some of the more important concepts in DAX, and understanding these three things will provide the best foundation on which to build your DAX skills. So first of all, you have syntax. Now before you create your own formula, let's look at the DAX formula syntax. Your syntax includes the various elements that will make up a formula, or simply put, it's how you basically code or write a formula. This is a simple DAX formula for a measure. Now keep a couple of things in mind. This formula includes certain syntax elements. Now people who are from a coding background will understand what syntax is. It's a grammar for using a certain programming language. And it's the same thing in context of DAX as well. Now first part, the measure name is total sales. Second, the equal sign operator indicates the beginning of the formula And when you make a calculation, it will basically do the role of giving you a result. Then sum is your DAX function. This is going to add up all of the numbers in the sales amount column, and this is something that we are going to discuss later. But for now, I have taken sum because everybody understands what a sum is. Then you have your parentheses or your round brackets, which surround an expression that contains one or more arguments. All functions require at least one argument to run, and in an argument, you basically pass a value to the function. Sales here is the table that you are trying to reference, and sales amount, as I had mentioned before, is your column in that particular table. With this argument, the sum function knows on which column to aggregate a sum. Now, when trying to understand a DAX formula, it's often helpful to break down each of the elements into a language you think and speak every day. For example, you can read this particular formula as the sum of values in the sales amount column in the sales table will give you the total sales measure. When you add this formula to your report, this measure will calculate and return values by summing up the sales amount for each of the other fields. Now you can always go ahead and create your own measure that sums up the values from the sales amount field, but the good part about this method is that this measure will make your formulas and your model more efficient. Now the best way to learn DAX is to create some basic formulas, use them with actual data, and see the results for yourself. So let's go ahead and create a simple formula, and this task will basically help you understand your formula syntax and how the suggestions feature in the formula bar can help you while creating your formula. Now here I'm using the Contoso Sales sample Power BI desktop file, which is an open source file that I've gotten from the Power BI website. If you go on to their website, you can get it too. But for your convenience, we are going to link this also in the description box below. So this is what your data model looks like. Couple of complicated relationships here. If you do not understand the concepts of relationships, do refer to the tutorial link I'll leave in the description box below, and then come back to this and finish this video. But it's not that important. We are here to learn DAX. So let's go back to our report view. Now this is our report view. This is where we create our visuals. So in the fields list, I am going to right click the sales table and select new measure. This is where we are going to be creating our new measure. Let's go ahead and name this sales for previous quarter or previous quarter sales. All right. Now after the equal sign, which will appear automatically, let's type calculate. Now you'll see this wonderful thing that Power BI is smart enough to suggest a bunch of things which start with CA. The Smart Complete helps you use DAX in Power BI even if you're new to DAX or programming in general. It will also give you a suggestion on how to use this particular function. Now that's brilliant. So what you're going to do is you are going to use the calculate function to filter the amounts we want to sum by an argument that we are going to pass through the calculate function. People who understand coding will refer to this as a nested function. Now, as you can see in the suggestion below, the calculate function has to have at least two arguments. The first is the expression to be evaluated, and the second one is a filter. Now, after this parentheses, we're going to type sum, okay? And then begin by typing sales, through which sales will come up, and let's see, yeah, this is what we want. We want sales amount. And then I close the parentheses. Now this is the first expression argument for our calculate function. Now after the comma, I'm going to keep a space to specify the first filter, and then I'm going to use the previous quarter time intelligence function to filter the sum results by the previous quarter. Okay. So after opening the parentheses, let's type, I'm going to put in calendar and date key. Now the previous quarter function has one argument, a column containing a range of dates basically. In our case, that's the date key column, and then I'm going to close both the arguments. Your formula should now look like this. So I'm going to go ahead and commit. I'll take some time, and here you can see your measure has been created. Okay? So congratulations, you did it and created a complex measure by using DAX. And that also, this is not one of the easy ones because it has nesting, it has so many advanced functions. But what will this formula do? What it's going to do is calculate the total sales for the previous quarter depending on filters applied in your current report. So for example, if we put sales amount and then previous quarter, so you were just introduced to several important aspects of DAX formulas. This formula included two functions. One is your previous quarter, which is a time intelligence function, which in a nested argument passed to calculate, which is a filter function. DAX formulas can contain up to 64 nested functions, even if it is highly unlikely for a formula to ever contain so many nested functions. Such a formula would obviously be very difficult to create and debug, and probably wouldn't be very fast either. But in this formula, you also used filters that narrowed down what will be calculated. In this case, you selected one filter as an argument, which is actually a result of another filter. You use the calculate function, which is one of the most commonly used functions in DAX. As you go ahead and author models of your own and create more complex formulas, you'll likely use this function many more times. Although any further discussion about the calculate function is outside the scope of this particular session. As your knowledge of DAX grows, my advice would be to pay attention to this particular function. Now, the next thing that I need you to understand, which is a very fundamental aspect of DAX, is context. Now, in DAX, there are two kinds of contexts. You have row context and filter context. First, let's look at the simpler one, which is the row context. And this applies whenever a formula has a function that applies filters to identify a single row in a table. This is something which you apply even without knowing that you apply this. The function will inherently apply a row context for each row of the table over which it is filtering. And like I said, this is most often applied to measures, and you're probably doing it anyway without even knowing about it. Now, the filter context is a little more difficult to understand than a row context, and you can most easily think of the filter context as one or more filters applied in a calculation that determines a result or a value. It doesn't really exist in place of row context, rather it applies in addition to the row context. For example, to further narrow down the values to include a calculation, you can apply a filter context which not only specifies the row context, but also specifies a particular filter. For example, when you add total cost to a visualization and then add year and region, you're defining a filter context that selects a subset of data based on a given year or region. But why is this particular kind of context so important to DAX? Now, one of the reasons is because it can basically define a function by relationships and by other measures and columns. Now, to better understand this formula, we can also break this down much like other formulas. This includes the measure name, which is store sales, the equal sign operator, which I had discussed before, the calculate function, which you just used, your parentheses, which surround your expression, a measure, which is your total sales, and then you have a fully qualified referenced column, which is your channel name in your channel table. Now, this is our row context. Each row in this column specifies a channel such as store or online. Now, the particular value store here is a filter. This is our filter context. This formula ensures that only sales values defined by the total sales measure are calculated for rows in the channel name column of the channel table, with the value store used as a filter. Now you can imagine being able to define your filter context with a formula has immense and very powerful capabilities. The ability to reference only a particular value in a related table is just one such example. Now don't worry if you completely don't understand context right away. As you go ahead, learn more, create your own formulas, you'll obviously get a better grasp of this concept and why it is so important. Now let's go ahead, look at a few functions. what they are, and how you can use them in your reports. So functions are basically predefined formulas that perform calculations by using specific values. Now these values are called arguments, and you basically are going to use them in a particular order or structure or syntax to suffice your function. Now arguments can be other functions, other formula, expression, column references, numbers, text, logical values such as true and false, or other constants. And if you're familiar with functions in Excel formulas, many of the functions in DAX will appear very similar to you. However, DAX functions are unique in some ways, such as the customizing calculations based on a row by row method, or the fact that many functions return a table rather than a value, and also the very important time intelligence functions. So let's go ahead and look at a few of these. So first we're going to start out by some simple functions. We're going to start out with some count functions and discover a few different variations of the same function. So again, I'm going to go ahead and click on new measure. And let's go ahead, name this our count measure. I'm probably going to try and reuse this for all the three cases that I'm trying to demonstrate. It's not very complicated. You just type count and wait for Power BI to auto-complete it. And then you pick, let's say, I'm doing product category. Then I'm going to go ahead and commit. As you can see on the right, this measure has appeared. If I drag and drop this on my screen and then maybe pick the card visualization, it is going to give me the exact count of the number of cells that contain numbers. Say the count function, it's basically going to give me the number of cells in that particular column that contain numbers. So we have 8 of those in this. Now remember, the count function is only going to return a whole number, and the only argument that is allowed to this function is a column. The count function counts rows that contain either numbers, dates, or strings. When it finds no rows to count, it basically will return a blank value to you. Your blank values in your columns are going to be skipped, and your true and false values unfortunately are not supported because you cannot count them. Now, if you want to evaluate a column of true or false values, you can go ahead and try a variation of count, which is the count A function. You can use that to count logical values or text. What this is going to do is it's going to count the number of non-empty cells in a particular column. So let's go ahead and try that. I'm going to go ahead and use the very same measure that I had created. Okay. Let's name this count A. And here let's go ahead and count A. Now, as you can see, the syntax has not changed and our value has also not changed, which possibly means that all of the cells in that particular column, which are not empty, actually contain numbers, and there are no empty columns. Now, like the count A function, you have something known as the count AX function, which counts the cell containing any kind of information, including other expressions. For example, if a column contains an expression that evaluates to an empty string, the countAX function treats that result as a non-blank. Usually, this function will not count your empty cells, but if it contains a formula, it is counted. Whenever a function finds no rows to aggregate, this one, like both its sister functions, returns you a blank. So my next example is going to show you how countAX works by counting the number of non-blank rows in the column using a filtered form of the stores table on status off. For that, you need to see what the table looks like. Here's the table. This is the close reason you measure. Let's just name it something, which is close reason. All right. Again, let me tell you, basically we are trying to get a count of how many of these stores are closed by filtering out the number of non-empty cells in the close reason column. Okay, so let's go here, and if we turn it into a card, it's giving us the number 12. Let's go to our data and see if that is true. Let's go down, 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 down. I'll keep it here for some time. You can go ahead and count the number of rows, and it's actually 12 rows which have the status off and a close reason. So that is the number of non-empty cells in this particular column, and we have used the countax function to count them. So next, let's go ahead and look at some logical functions. Now, these are the functions which are going to act upon a certain expression that you pass on to them and return you the information about the values given by the expression that you put in. Yes? For example, you can use a function known as if to check the result of an expression and create conditional results, because the word if, even in English, is used in a conditional context, right? So in this category, I'm going to discuss the three most common logical functions, which are and, or, and not. Another very popular one used more commonly is the if error, which basically evaluates an expression and returns a very specific value if the expression returns an error. So let's go ahead and look at our first function, which is the AND function, which does nothing but check whether both arguments that you have passed through it are true or not. If both of them are true, then it returns true, otherwise false. Now the syntax is fairly simple. All you have to do is put in two logical arguments after the AND, and it's going to return a value depending on the combination of values that you test. Now, if you need to perform an AND operation or multiple expressions, you can create a series of calculations, or better, even use the AND operator that you use while coding, which is the double ampersand sign, and join all of them in a simpler expression. As for this particular function in DAX, it accepts only two logical arguments, hence that's what we are going to do. So I'm going to go ahead and create a very simple measure again. And let's call it the logical measure. Again, like the previous time, I'm going to try and reuse this as many times as I can. Now, basically what this measure is saying is that if 10 is greater than 9 and minus 10 is less than 1, then we are supposed to be returned all true, else one or more false, which is just a good way of saying true or false. We're going to go ahead and test it. And if I just click on this, if you see both of the conditions, they are true. 10 is greater than 9 and minus 10 is less than minus 1. So our conditions are both true. Now, if I go ahead and change this up a little bit, instead of minus 10, I make it plus 10 and then commit, you see the value changes, right? So for the AND function to return you a true value, both of the logical arguments passed through it should be true, else it will be false. Now let's go ahead and try out another very popular logical function, which is the OR function, which basically checks whether one of the arguments is true. Now, like the AND function, the OR function in DAX also accepts only two arguments. So if you need to perform an OR operation on multiple expressions, you can create a series of calculations by using the OR operator. Also, this function evaluates the arguments until the first true argument and then returns true. So keeping that in mind, let's go ahead and switch this up a little bit. Now we know from our previous example that one of the arguments here is true and one of them is false. So instead of keeping this quote as all true, let's switch this to at least one true. And let's switch this to both false. All right. We're going to switch the and to an or function. And we're going to go ahead and commit our changes. Now we remember from the previous example that one of them is true, 10 is greater than 9. The second argument is false. So our card shows at least one is true. Now let's change the 9 to 11 and see what happens. As you see, the card shows both of them are false. So now that we've seen and or, let's look at not. What it does is that it changes false to true or true to false once you pass a logical argument through the not function. Your return value will be true or false, and you're basically going to pass just one argument through this particular function. So what I'm going to do is I'm going to make these changes here. I'm just going to keep one side as true and one side as false. Here we're going to switch this. Let's remove our second argument and replace the or by not. So 10 is not greater than 11. It's a false statement. So since we are passing it through the not function, we should get a true, which is why we're getting true. And let's flip this and see if we get false. And here you go. With that, we've looked at a certain logical functions. Let's go ahead and see what the next type of function is. Next, we have our information functions, which basically look at a cell or a row that is provided as an argument and tell you whether the value matches the expected type. For example, the isError function returns true if the value that you've referenced contains an error and false if it does not contain an error. All of these functions are pretty true to their name and are fairly simple to follow. Now the next one we're going to look at is a function called contains, which returns true if values for all the referred columns exist or are contained in those columns. Otherwise, the function will return you false. So basically, true if all those values exist and false if they don't in the column that is specified. Now make sure that your column is not an expression and your value is basically a sort of a single scalar value. The arguments, column name and value must always come in pairs, otherwise you will be thrown an error, and the column name must belong to the specified table. Now next you have a function called username, which is an expression with no parameters. It returns the domain name and the username from the credentials that are given to the system at the connection time. The code you see here basically verifies if user login is a part of a certain table or not. It's as simple as that. Your return value is going to be the username from the credentials given to your system. The same logic applies to two other information functions, namely user object ID, which returns the current user's object ID or SID, and the user principal name, which basically returns the user principal name as the name suggests. Next, let's go ahead and discuss some text functions. Now DAX includes a set of text functions which are basically based on the library of string functions if you have worked on Excel before. Now these functions have been modified to work with tables and columns in tabular models of Power BI, but if you worked with them using Excel, it might come naturally to you. Now the first one we're going to look at is concatenate, which as the name suggests, it concatenates two text strings into one text string. You're basically going to use the function and then pass two different texts, and then your function is going to concatenate or join those texts. Now the joined items can be text, numbers, or Boolean values represented as text or a combination of those items. You can also use a column reference if the column contains appropriate values. So again, if I go ahead and create a new measure, let's try and concatenate the commonest text that you can, which is hello world. See, it's as simple as that. Now you can go ahead, do the same thing with numbers or Boolean and work with it as you like. The next function we're going to look at is exact. Now what it does is that it compares two text strings and returns true if they are exactly the same and false otherwise. It's pretty self-explanatory, and one thing you have to remember is exact is case sensitive but ignores formatting differences. So you can use exact to test your different strings being entered into a document. So let me switch the second word to hello, but maybe with H capital. And as you can see, because it is case sensitive, it's going to return false. Now this is great if you want to compare two different columns and their values from two different tables that you have updated from, let's say, two different individuals. So you can sort out the differences and see where the irregularity lies. So the next text function we're going to discuss is upper. I'm going to go over this pretty quickly. It converts a text string into all uppercase letters. So if I used upper and maybe, let's say, now the next and the most common functions that are used in DAX are in fact the date and time functions. As the name suggests, these functions help you create calculations based on dates and time. Now again, if you have used these in Excel before, they are very similar to the date and time functions there. However, like we saw in many other functions prior to this, the DAX functions in Power BI take values from a column as an argument. So I'm going to go through a couple common ones very quickly, and then we're going to discuss a few common time intelligence functions, which are a section of their own. So first of all, let's discuss today. Now this function is very useful when you need to have the current date displayed on a worksheet, regardless when you open the workbook. Although it is most commonly used for calculating intervals. So I'll quickly go on to DAX and use this function. Okay, so we're going to go click on new measure. Let's call it the date measure. And then commit. Now, if I had to display this on a card, it would give today's date. But a DAX function simply can't serve this purpose. It has to have more of a purpose than just showing the date, right? So suppose if you know someone was born in 1955 maybe, you can use this formula to find that person's age as of this year's birthday. So here we are going to use another function, which is the year function, and subtracting 1955 from it. Let's commit. And you know that person as of this year would be 65 years old. This particular formula uses the today function as an argument for the year function to obtain the current year and then subtracts 1955, which will return the person's age. Now that you've already seen how you use the year function, let's go ahead and look at it from a definitive standpoint. Now, as the name suggests, your year function will return the year of a date as a 4-digit integer, and that goes for all of Microsoft's spreadsheet-based applications and softwares. If you try to use date and time functions before the March of 1900, you'll probably get an error. Now, you need to understand that in contrast to Microsoft's Excel, which is basically storing your dates as serial numbers, what DAX does is it uses a date-time data type to work with dates and times. Dates should be entered by using the date function or as results of other formulae or functions. You can either enter dates in accepted text representations of dates, such as 22nd June 2020 or June 22nd, 2020, depending on where you're from. Now, you need to keep in mind that errors may arise if the format of strings is incompatible with the current local settings, and you'll have to take care of it as you go along using this. Another one, like the today function, is actually the now function, which not just returns the date, but also the time in datetime format. Now, the now function might seem only useful when you need to display the current date and time on a worksheet, but it is also used to calculate a value based on the current date and time, and when that value is updated each time you open the worksheet. The result of the now function changes only when the column that contains the formula is refreshed, so please do not expect it to get updated continuously. Now, the last one I want to discuss is not just a date time function, but also a time intelligence function. Now, what a time intelligence function does is that it enables you to manipulate data using time. Now, this includes dates, months, quarters, and years, and you can then build and compare calculations over those periods of time. Now, one in particular which is used a lot is the dates in period function. Now, this basically returns a table that filters out your column only between a certain period of time or in between your start date and end of interval. It returns to you a table containing a single column of date values. So one very commonly used time intelligence function is your end of month function. It could be your end of quarter or end of year function as well. Now, what these kind of functions do is they return the last date of the month in the current context for specified column of dates. This table contains a single column and a single row with a date value. Now, this could be a reference to the date and time column, a table expression that returns a single column of date time values, or a Boolean expression that defines a single column table of date and time values. Now, one thing you need to remember is that you cannot use this in the direct query mode. So let's go ahead and look at a sample to create a measure that creates the end of the month for the current context. Let's call it end of month or EOM and use it directly. Now, like I said, you can use the end of quarter or end of year as well, depending on what your company uses, and put in the date key. Let's drag it out and put it in a card, and here you see your end of month. You can go ahead, drag it into a visualization and see how it affects your visualization. And you can also use the other variations of this, such as you can change end of month into end of quarter, which will basically give you the date for the end of quarter. This is the end of my quarter, so that's that. With that, I think we have covered all the common functions that there is to know about. You can obviously go ahead, look at the official documentation for DAX and see for yourself the entire plethora of functions that are available at your disposal. Now that you have a basic understanding of the most important concepts in DAX, you can begin creating your own formulas for measures of your own. Now, this can indeed be a little tricky to learn, but there are amazing resources from Power BI's itself site for you. After experimenting a little bit on your own, you can learn more about these concepts and formulas which will help you solve your business problems. And because it has been around for several years and works with other Microsoft business intelligence softwares, there's a lot of great information as well as a very strong community out there. You can find more information in books, white papers, and blogs from both Microsoft, leading BI professionals. And if nowhere there, you can always come back to our blogs and videos to clear out your doubts. If you have trouble running any of the functions I showed today, you can leave your queries in the description box below. I'd encourage you to experiment as much as you can That is the only way to learn. With that, I close this session. My name is Upasna. Thank you and have a great day.